With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that the current I1 in ampere flowing through 8 ohm resistor in the following circuit is. So we have to find out what is the value of I1 which is going to flow through 8 ohm resistor in the given circuit. So the applied potential difference is given to be 8 volt. There are multiple resistors connected here, 8 watt in parallel, and this parallel combination is in series with 4 watt, and that series combination is further in parallel combination with 4 watt, and then this entire setup is at a potential difference of 8 volt. So basically let's try to understand the behavior of potential difference and your current. So we have learnt, when we have tried to derive or understand the combination of resistors, we have learned two important things. One thing is that in the parallel combination, the potential difference across each and every resistor is going to remain the same, whereas in series combination, the current is going to remain the same. So obviously in parallel combination, current will depend upon number of paths, so it's going to get divided. So based on that, let's say I is the current which is produced from the source, that is from your 8 volt cell or battery. So now as soon as I has come to this point, it finds two paths. One, let's call it as I dash, and another one I'll call it as I double dash. Now this I double dash further, it's going to find out two paths, I1 and I2, and further they will combine to form I double dash, and then they will combine to form I double dash plus I dash, and again it was going to be I. So now this was about the current behavior. Now let's talk about the potential difference behavior. So potential difference across 4 watt is now going to be 8 volt. The potential difference across the combination of 8 watt and the 4 watt to put together is also 8 volt, because these two are in parallel to each other. Now to find out the individual values of the currents, we have to find out the equivalent resistance, or there's also another method wherein I can find out I dash by Ohm's law, which I am going to get it, and then I can find out I double dash also. So we'll go with the first method of finding equivalent resistance. So to find out equivalent resistance, we have to simplify the circuit. Therefore, the simplified circuit will now look like, so 8 watt are in parallel. So since 8 watt are in parallel, that is going to give me a resultant resistance of 8 and 8 in parallel, two equal resistors in parallel. So that resistance divided by 2, 8 by 8 is 4. So that is in series with 4, and then further it is in parallel with 4. So 4 and 4 in series will now give me 8 ohm, and then it is in parallel with 4. Therefore, we know the formula to find out the parallel resistance. Parallel resistance is nothing but R1 R2 divided by R1 plus R2. So let's substitute for R1 and R2. R1 value is 8, R2 value is 4, divided by R1 plus R2, which is 8 plus 4, which gives me 12, for 1 times, for 3 times. Therefore, the equivalent resistance is 8 by 3 ohm. Since I know the equivalent resistance, I can also find out what is the equivalent current. So the total current. So to find out the total current I, we can use Ohm's law. V is equal to IR. Therefore, I will be equal to now V divided by R. V is 8 volt which is applied. Resistance is 8 by 3. Therefore, this is now going to be 3 ampere. Therefore, 3 ampere will get divided into I dash and I. So I can also calculate I dash. So to find out I dash, again we will be using Ohm's law. That will be nothing but V is equal to I into R. So same potential difference, 8 volt will be generated. I dash into resistance is 4. So I'll be getting I dash now as 8 divided by 4, which is 2 ampere. So I got to know that out of the 3 ampere which is generated, 2 ampere is flowing through the 4 watt, and remaining 1 ampere will be flowing through I double dash, because by conservation of energy, that is charge, current I will be equal to I dash plus I double dash. So this implies that I double dash will be equal to 1 ampere. So out of this 1 ampere further, I1 will get divided across 8 ohm, I2 will also get divided across 8 ohm. So now across each of it, the equivalent resistance which we found was 4. So we know that entire of 8 volt is divided across 4 and 4. Therefore, since the resistance is same and the current is going to be remain same, so 4 volt will be dropped across the first combination, 4 volt will be dropped across the second combination. Therefore, I can say that 4 volt is the voltage across the 8 watt. So from this I can again use Ohm's law. So using Ohm's law further, again V equal to IR. Now V across the given resistance 8 ohm, V value is 4, current is called as I1, resistance is 8, therefore I1 will now be equal to 0.5 ampere. So I1 across the first 8 ohm resistance is also 0.5 ampere. The second resistance is also 0.5 ampere, which adds up to be 1 ampere and then it flows through 4 watt. So from this we can say that the current flowing through the 8 ohm resistor will be 0.5, which is option 2. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.